All right, welcome back. Algebra 1. We are in section 7 today, guys, and we are doing the oh-so-famous quadratic formula. Okay, I'll be honest, I'm sure there's plenty of you that have never heard of the quadratic formula, but if this is your first time, welcome to the famous quadratic formula. If this is not, then I'm sure you know a little bit about what you will be working on in this section right here. Welcome to the quadratic formula. Okay, so the quadratic formula, this is another method that is used to solve polynomials, specifically quadratics. And quadratics are polynomials that possess that right there, the x squared, or variable squared, doesn't have to be x. And this is the quadratic formula. So I'm going to zoom in a little bit more if I can. And I need you guys to make sure you are copying this down. This is vital. This is important. This is also important because the quadratic formula is a method that will work every single time. If you are ever asked to solve a quadratic, or another way to say it is they could say find the roots. Another way they could say it is find the x-intercepts. All of those things are the same. All right, so I'll say all three again. If they say solve the quadratic, they could say find the roots, or they could say find the x-intercepts. All three of those are all saying the exact same thing. And all three of those can be gathered by this one formula right here. All right, so that formula right there includes all three parts of the polynomial, or you could say all three parts of the trinomial, or you could say all three parts of the quadratic. It's all, again, basically the same. So you have to have your A, your B, and your C value, because you'll see right here we use A right there, we use B right here, and we use C right here. Now, if you are not given a value, let's say we don't have a bx, we don't have this middle part right here, then what does that tell you about b? It tells you b would be 0. All right? If you don't have a c value, then that tells you that c would be 0. Now, here's the only difference, though. If you don't have A clearly written, then that means A is actually equal to 1. Okay? That is one of the key factors, is that A could just be 1. A could be a negative number, that's true. But if you don't have a clearly defined A value right there connected to the x squared, then that means that A is 1. All right. So let's zoom out. Here is a little concept summary of now every single method that you have learned, you've been exposed to, you have tried out, except for this one right here because we are just working on this now, quadratic formula, but you have gone through factoring, you've gone through graphing, finding square roots, completing the square, and now officially the quadratic formula is now being introduced to you. Now, where are all of these discussed? These are all the sections in the textbook where they are discussed. Okay? Now, I've highlighted the basic part of the definition as it's saying when to use it. And the one part here with graphing, I just don't recommend it in Algebra 1 being used as a very strong method in solving a quadratic, because graphing usually means it's hand-drawn and it could be not as precise as necessary. But all of these methods right here are precise. However, when it comes to methods that work every time, quadratic is my favorite. Completing the square works, but I believe that once you give the quadratic formula a try, use it a few times, it's not bad. Okay. So let's take a look here. Finding the roots, just as I said, it's the same thing as finding the x-intercept and solving. Those are three things I've already discussed. Okay, let's take a look at an example problem with the quadratic formula. So it's saying find the roots. That just means solve it. Here is the given quadratic. All right, your a value is 1 because look at, they don't give you any a value in front of that. So that is 1. Your b value is -6. Your c value is 3. All right, but what you have to see here also, look at that. It says -b. That's the equation, or sorry, that's the formula telling you -b. But look at this. They give you b already as a negative. That negative with that negative, what do you think is going to happen? Because that's two negatives. Well, let's zoom in. Negative and negative is going to change it to a positive. So this is something to pay attention to. If the b value is already given as a negative, and then you plug it in right there where there's another negative, it's going to turn it into a positive. All right, something to pay attention to. Now, if we zoom out just a little bit, again, like I said, your a value was 1. That's right there. Okay, so see where a is right here? There's the 1. That's a. There's an a right here. There's a 1. That's a. This -4 is given. That's a part of the formula. So if you're ever wondering, where did that come from? That's a part of the formula. So you don't have to see that up here. That will always be right there. And that's right there. Okay, so b, as we already went through right here, is actually going to become a +6. Now, notice this b squared. We like that because no matter what, when you square something, it becomes a positive. So -6 came from right there, -6. We're going to square it. It's going to become a +36. Then you're going to have this -4 times 1 times 3, and then you will have to subtract that. So all of this underneath that big square root simplifies to simply 24. 2 times 1 is 2. Don't forget your double negatives. Make that 6 become a +6. And you can't forget how to simplify radicals. This goes back a few lessons, I know, in other chapters, not in this chapter, but we've learned about simplifying radicals, and that comes back. So you have to remember simplifying radicals. And how do we do that? We use a factor tree. Okay, so all of this worked out here. Square root of 24 simplifies down to 2 square root of 6. That's because 24 can be written as the square root of 6 and the square root of 4, and the square root of 4 is 2. So there's your 2, there's your 2. There's your square root 6, there's your square root 6. Now what I want to zoom in on is the fact that we actually have 3 values that are outside of a radical, and all 3 values are divisible by the same number. All 3 of these are divisible by 2. That is why that 2 and that 2 will disappear, and that 6 will disappear, becoming a 3 right there, leaving us with 3 plus or minus the square root of 6. All right, so that's how we get down to that solution. Let's go ahead and take a look. One last little note right here, by the way, is if you can factor, remember factoring, okay, so that's breaking it down into double parentheses. That was back in last chapter. If you can factor, that is actually the fastest method to solve a quadratic. It really is the fastest method. But as this says, the quadratic will work every time. So what I tell students is if you're comfortable and confident enough with factoring, you could do factoring as your first step, but you may determine that it actually can't factor. And if that's the case, then you must use the quadratic formula. I have other students that always say, I just don't like factoring that much, but they're fine with calculations, which is what the quadratic formula is all about. It's just calculations. So they stick to the quadratic formula every time, and that's okay too. All right, so figure out which category you fit into. I like factoring, or I don't like factoring, but pick one and stick with it. All right, so let's do some example problems here. First, all of these we're solving, we're getting the roots, so that's why the directions aren't really written there. All these are the same. Okay, so I can tell you right off the bat that this first problem, this does not factor because 1 cannot somehow become 4. So we have to use the quadratic, all right? So let's go. We have a negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So that is me setting up the whole quadratic formula, all right? So here's my b value. It's a positive 4. Remember, there is a negative sign there, so that's why it becomes a negative 4. And that's b squared. That minus 4 is given in the formula. A is 1. C is a negative 1. And then that's a again right there. So now what we have to do is we have to calculate and figure out what is the answer of just this part underneath the radical. Okay, so we have 4 times 4 is 16. And that's going to be negative 4 times 1 is negative 4. But then another negative 1 is going to actually be plus 4. So that's going to give you a square root of 20. Let's rewrite this. So we have negative 4 square root of 20 divided by 2, right? And now we're going to have to simplify this radical. So let's zoom in a little bit here. We have to simplify radical 20, which can be simplified. I would recommend breaking that down into square root of 4, square root of 5. All right? And then the square root of 4 works out perfectly to be 2. So now what we're going to do is we're going to rewrite what we have here. We no longer have the square root of 20. What we do have is 2 square root of 5. So now what we have is negative 4 plus or minus 2 square root of 5, all divided by 2. All right, so take a close look at what we have here, because in our last example problem, you were told, and by the last example, I mean this one right here that you're looking at, that if all 3 parts were divisible by the same number, then you could do something. You could reduce, all right? And you could reduce, which means all are reducible by 2. So let's simplify this. These 2's will cross each other out, and this will reduce to become a negative 2. And let's go ahead and right over here, what do we have left? We have negative 2 plus or minus square root of 5. That is our solution right there. Okay, so that's a good example problem to see where you have to use the quadratic. You are simplifying radicals and you are reducing numbers at the end. This is as detailed as these problems are going to get. Quadratic, simplify radical, reduce at the end. That's every possible step. All right, so let's take a look at example problem number 2. Don't forget, if you want to see example problem 1 again, rewind this, go back. Okay, I know that that doesn't come natural. You don't want to do it, but if you want to learn it, you'll take the time. All right, let's take a look at this one, because this, if you look closely, is actually pretty nice. And by nice, I mean it factors. So let's do a little factoring review. Double parentheses, plus sign, then a minus sign. That means in here we're going to go minus, minus. X squared breaks down into x and x. Now, this one is also special because it is a perfect square trinomial. That means 16 is a perfect square. 4 and 4 make 16 when you multiply. 4 and 4 make 8 when you add. So that is why this is a perfect square. Sorry, let's get the same color here. 4 and 4. That means that, by the way, we're not done. You have to solve your parentheses, but we're only going to have one answer. That one answer is simply 4. Remember how I got that? X minus 4 equals 0. X equals 4. That's how we got that. So this one was factorable, worked out perfectly, got a simple answer of just 4. All right, let's do our last example problem right here. I can tell you again, this one's not going to factor. Quickly looking at this, you can see factors of 5 are 1 and 5. They cannot magically just create another 5. So we will have to use the quadratic formula. Negative b, which is 5, plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. All right, so let's work this out here. We have underneath the square root, we need to simplify all of that. So we're going to have 5 squared is 25. Then negative 4 times positive 1 makes negative 4. And negative 4 times negative 5 makes a positive 20. So that means we have 25 plus 20, which, once we rewrite this, this is what we're looking at. That will be 25 plus 20, giving us 45. So the square root of 45 divided by 2. All right, so this underneath the square root made 45. When you simplify all that, that's how I got that. Now we got to simplify the radical again. This 45 can be simplified to square root of 9, square root of 5. This is why we liked 9 and 5, because square root of 9 is 3. So that means that the square root of 45 simplifies to 3 square root 5. So that's what we're going to need to write over here. Negative 5 plus or minus 3 square root 5, all divided by 2. Now, if we look at these 3 values, they don't share anything. If they don't share anything, 2 and 3 and 5, they don't share anything. I can't reduce them. And that means you are done. This one can go no further. That is it. Negative 5 plus or minus 3 radical 5, all divided by 2. big answer. It looks a little complicated there, but give it time. Practice this. Work hard. Bring your questions to class. All right? So let's do a little zoom out. There we go. There's your example problems all worked out, all on one screen right there. That's what I got. All right. So like I said, keep working hard. Bring your questions to class. I will see you guys in the next video.